Okay, we're just going to look at transformations, and we're going to look at the two features that we're going to talk about are amplitude and period. So amplitude and period, basically what we're dealing with amplitude is the strength of the wave, if you will. So the wave, basically, if you take a look here, how far it goes up, where it maxes out, and where the minimum point is, how big that wave is, that's the amplitude. Okay, and then the period is how far it takes the graph to complete a complete cycle. That's the period. All right, so those are the two things that we're going to look at. And what we're going to look at is just, if you go to a basic parent function of a sine graph, right? Parent function of a sine graph is basically this, right? So the period, which is where this thing begins and where it finishes. So it starts at 0, it maxes at 90, it comes down through, it mins at 270, and then gets back to 0 at 360. That's a complete cycle. That is the period of the graph. Now the period of a parent function of sine x is at 360 degrees. Right, finishes at 360 degrees. So that's one complete cycle. Same for a cosine graph. Exactly the same. So if we look at a cosine graph, again, it finishes itself. So it starts in a different place. It starts at 1, comes through at a minimum point at -1, and then comes up and finishes at +1 again at 360 degrees. So up, down, up. Max, min, max. That's a complete cycle at 360 degrees. So cosine is also 360 degrees, right? So that's what we mean by a period. And an amplitude, again, is the strength of the wave. Now, if we go back to those graphs and we look at their waves, where does this graph max and min out, right? So we have, basically, with these parent functions, we have a line of symmetry that comes through the x-axis, and then we have a max and a min point. And that max point is 1 and -1. So basically this distance here, right, from the line of symmetry to the min point and from the line of symmetry to the max point, that's your amplitude. In this case, it's 1. It's not a like a positive or a negative. It's just 1. That's the distance from the line of symmetry. So that's our amplitude. So amplitude is the size of the wave of the graph, so it's the max and the min points. If the graph has a line of symmetry at the x-axis, then the height above the x-axis is basically the amplitude. Like here, we have basically the line of symmetry is your x-axis, so if you can just count how far up or how far down it went, that's your amplitude. If the graph has a line, otherwise we'll need to calculate it. So the thing is that most of the time we have to calculate it. So with this little formula here, max minus min divided by 2. That's how you basically do the calculation of finding the amplitude. So again, if the max was 1 minus a -1, right, all divided by 2, that's 1. That's why the amplitude is 1. It's not a negative or a positive, it's just a 1. Now, the basic frame of an equation, so we start to look at transformations. So we're going to start looking at this k out in front of the sine x and this c. So this should start looking familiar because we did something similar with quadratics in year 11 with transformations of quadratics and so on in graphs. So if the equation k is a constant, that determines the amplitude. This thing here determines what the amplitude is. Okay, so we're going to go to this link, and you can do this with me if you're on your OneNote, or you can just watch, or you can sort of click this link, if you will. Come on. Click that link. Open. And go to Desmos, so you can kind of pause the video if you want in a second, And all I want you to do is play around with the k's, right? So it says in the OneNote that it wants you to basically move the k to 2. So let's just do that. So move the k to 2, and let's look at the graph. So here is our max and min. Oh, well, the graph changed to 2.1, but you get my idea here. It's a little bit tricky to get that to stay there. Yeah. So there's my amplitude. So my line of symmetry is my x-axis, and then the distance from the x-axis to the maximum point is 2. Again, you could say, okay, well, it goes from positive 2, that's the max. Max is, come on. Max is negative 2 to positive 2, right? So again, if you wanted to calculate it, well, you just go max minus the minimum, which is going to be positive because 2 negatives divided by 2, which is 4 divided by 2, which is 2. That's the amplitude. So that number in front tells me what the amplitude is going to be. All right? We've dealt with amplitude. Now the second thing is we're going to look at the period of the graph. And we're going to go to the Desmos link here and find out what the b does to the sine graph or cosine graph. Okay, so we have a slider b, so let's just go to our link here again. And now we've got the sine graph, but we're going to go down here and we're going to take a look at, we're going to undo that one and we're going to put this one up. And we're going to see what b does. So we're down here to the slider at the very bottom. And we can see that as b gets bigger, it compresses the graph. So b is changing the period. So normally, the period, when b is basically 1, if you will, and get it to 1, look what happens. You've got starts at 0, finishes at 0. That's a complete cycle, 360. Look what b is. b is 1. Okay, so we don't actually write that, so that's why we get sine x. But if I move b to 2, look what happens. Where does the graph complete itself now? So we start at 0. Where does it come to 0 again for the very first time? Oh, 180. Well, so when b is 2, the period is 180. It's like half of 360. Okay, well, what if we do 0.5? Make b 0.5, like a half. What do you suppose? Oh, well, let's see. Where does it finish? It keeps on going, and it seems to finish right about there. What's that? 720. So it starts at 0, goes all the way, max, min, up to back to 0 at 720. So when b is 0.5, right? When b is 0.5, the period is 720. 720. Well, what's that? Well, 360 times 2 is 720. So when b is a half, basically, we've doubled the period. Right? We've doubled the period. So, yeah, changes period to 180. We did that. And when we do that, b is 2. If we moved it to 0.5, we've got a period that finishes at 720. So that's basically what we're doing. Now, to calculate that, to actually work that out, we have a calculation that we can do, like with amplitude. So basically, calculating b, or the period, basically is all you do is you take the normal period, which in sine and cosine graph is 360 degrees, and you divide it by your b. So if I've got y is equal to sine of bx. If I know what b is, then that will give me my new period, where it's going to finish, right? So if this is 2, then, so if I've got y is equal to sine of 2x, right? So I'm just going to divide 360 by 2. So I know that my period is going to be 180 degrees. If B is 0.5x, then I know that I'm going to just take 360 and divide it by half, or 0.5, which is going to give me 720. Now, more than likely, you're not going to know what B is. So this is kind of what more like we're going to have to do. So basically, if you know what the new period is, so if it's 360 divided by B is equal to the new period, then guess what? If we need to find B, you just rearrange the formula, and you're going to go 360 divided by whatever the new period is. Now that would be the calculation for giving you B. So when you need to find B, you simply take the 360 and divide it by whatever the new period of the graph is. And so we're going to see where that comes into play when we're going to be creating graphs and so on. Now we'll do the vertical slide just to finish this thing up. So the vertical slide is determined by whether the graph goes up or down is determined by C. And that's just a shift up and down. So C slides the graph up and down and moves the line of symmetry. So again, this seems quite similar to some of the things that we had done before when we were dealing with exponential graphs. So it can be calculated now. You make sure you don't confuse this with max and min point of an amplitude. We do max plus min divided by 2 to be calculated to find what C is. And it tells us a line of symmetry. So it's very, very important, this aspect of the graph, to know what it is. So the graph of y is equal to cosine x plus 3. Let's just take a look if we can go back to our little link. Yeah, let's go back to our link. So let's just turn that off. Oh, and that off. Oh no, we'll put that on. So let's move C around. See, now C doesn't do anything to the graph period-wise. So this graph's period is at 360 degrees. It simply slides it up. But the thing is, by sliding it up, it's also shifting the line of symmetry. Normally, the line of symmetry is at the x-axis. But if we slide it up 1, whoops. So when C is 1, that changes our line of symmetry to 1, right? And so C is very important because, again, if you look at the sine graph where it goes through the x-axis, it's no longer going through 0, it's going through at 1, right? So it's going through at 1, not at 0. So that's been a sine graph that has been shifted. So I could put, can I do this? Y is equal to C. C. Let's see what that does. Yeah. And so if I shift this graph around, that's kind of interesting, eh? So when I shift this graph and I shift the C, so I shift the C to 2. Yeah, 2. I have moved the line of symmetry and just moved the graph around. So now it doesn't go through 0, 0, it goes through at 2, 0. So that's what C is. And C is actually quite important for doing work with finding equations and things like that. So we're going to take a look next video at how this all comes together, and we'll do some work around this and some practice with this.